In this video, we're going to be talking about sketching the graph of an inverse function. So this first problem says, find the equation of the inverse f of x equals 2x plus 3, then sketch the graph of f of x and f inverse of x. So, first to find the inverse equation, remember f of x is the same thing as y, and we're going to switch x and y. So now it says x equals 2y plus 3. Then we solve for y. So I need to get y alone. I'm going to subtract 3 from both sides and divide by 2. And then replace my y back with the inverse function notation. So instead of writing y, I'm going to write f inverse of x equals x minus 3 over 2. So there's the equation. Now we can graph. So we want to graph both f of x and f inverse of x. I'm going to start with f of x because it's the easier of the two. It's a linear equation. Remember, let me rewrite this right here. F of x equals 2x plus 3. This is in slope-intercept form. So our slope is 2 and our y-intercept is 3. We always start with the y-intercept. So I go up 1, 2, 3 on the y-axis. And then I'm going to use my slope of 2, which is the same thing as 2 over 1. So from that point, I move up 2 over 1. Up 2 over 1. Or I could use two negatives. Down 2, back 1. Down 2, back 1, right? Two negatives make a positive as well. Down 2, back 1. So there's my line. Remember, we're going to try to fill the graph. So that is f of x. If I want to graph f inverse of x, if I wrote this in slope-intercept form, it'd be 1/2 x minus 3 halves. Now, I don't really want to graph halves. I want to graph whole numbers to be more precise. So I don't even have to use this slope-intercept form. I can use my f of x graph and just switch the coordinates, right? That's how we found the equation, is to switch x and y. So all these points on the graph, I just have to flip them and switch the x and y's. For example, this point is 0, 3. In my f inverse equation, it would become 3, 0. This point here is 2, 1, 2, 3, 4, 5, 6, 7. My inverse graph would be 7, 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. So it becomes 7, 2. So all of these points are just switching the x's and y's. This point down here is negative 3, negative 3. So that would be the same point when I flip x and y. And we can do this for all of the points. So 1, 1, or sorry, negative 1, 1 becomes 1, negative 1. And I'm just going to go ahead and connect the dots. I have enough points here to make a line. And we can see that this is going to be a mirror image across the line x equals y. And that should always be true with inverse functions. They should always be a mirror image of each other, because all we're doing is taking xy and flipping it to x, or to yx. Go ahead and try the next example. This example says, sketch the graph of the inverse of f of x equals 1/3 x minus 2. So we just have to find some nice points on this graph. There's a nice point, here's a nice point, there's a nice point. And we just have to flip the order of the x and y's. So this is the point 0, -2, this is 3, -1, and this is -3, -3. So when we flip those ordered pairs, it becomes -1, +3, and -2, 0, and -3, 3 stays the same because when you flip that, it's still -3, 3. So we get this graph here. Again, it's going to be a mirror image across that y equals x line, or x equals y. If you're not getting a mirror image, then something's happening, and you need to reevaluate what you've done.